All right, we run a tight ship. We're starting the stream officially. It is 9:30 Pacific time, so we're going to kick off. Welcome to GitOps The Planet, the only Twitch live stream that I do that's about GitOps. It's a very exclusive club. Today, we've got a pretty cool program for you. We've invited Davin, OneDrop, and Ryan Walter, who are maintainers on Kubernetes at home. So before we jump into that, housekeeping, we are live on Twitch. Of course, follow us on social media. We're at CodeFresh, and I am at Today Was Awesome. We'll have this recording posted on YouTube, usually within a few days, depending on how busy I am, how long the recording takes. But I think that's all the preamble I have. We're monitoring the chat, so keep that chat going. And let's welcome Davin and Ryan. Welcome, fellas.
Hi. Thanks for having us, Dan.
Thank you for having us on.
Yeah, I'm really excited about this because Kubernetes at home. I mean, first of all, I think you can see I've got my home lab over here, proudly displayed. That's part of it. The other half of it is sitting in a pile of Lego rack that I built over here, which is nonsense. But I first became aware of you because I gave a talk at KubeCon, I think it was 2 years ago, about building a home lab, and I built one with atomic pies. So I wanted x86 and I wanted it to be cheap. And I spent about $200 to build this home lab with a 5-node cluster, and I was really proud of it. And I felt like when I did this, that nobody was doing this. I felt like doing something in the home lab. It felt like I was doing something that nobody had done, because it was like doing Kubernetes, like bare metal, and that was hard. And then everywhere I looked, it felt like services didn't exist. Like everybody if they made services, they didn't Dockerize them. A lot of the home lab stuff was just for Raspberry Pis. I gave that talk, and somebody came sprinting up to me afterwards, and they were like, dude, you need to be in Kubernetes at home. And I was like, what is that? And he invited me into the Discord, and there were like, everybody was like talking about like, oh, KubeCon representing the home lab. And I was like, there's like a whole community of you folks. And so I was so excited to find you. So for those that aren't aware, maybe do you want to introduce like the idea of home lab and like why Kubernetes in the home lab? Like, why not Docker Swarm on a single node? Why have a home lab that's this serious?
Yeah, I can dive into that a little bit. So back in 2017, 2018, I was working at a company, and we were using basically Docker Swarm. And we just wanted to like automate more. We want to go further, and piqued my interest, Kubernetes. So I started learning it on and off, but it didn't really click with me until I saw like the GitOps pattern, where you have, an operator running your cluster that's able to deploy things for you. And I came across Jeff Bilemek and his GitHub repo that he had out there. I think he might have been the first one doing it. Don't quote me on that, but it was really interesting to see how he was using sealed secrets. Back then it was Flux version 1, but it was starting to fire things off in my head like, wow, this is really cool. And since everything is declarative in my Git repo, I can do a lot with this. Like secrets, everything going in my Git repo. It's little secrets being committed is a little, whatever. But, as long as you, pre-commit, use tools to help you prevent yourself from committing them unencrypted, it works out pretty good. But yeah, that's how pretty much it started. I brought up the Discord and just started throwing it on Reddit, throwing it on Hacker News, other places, and saying like, hey guys, if you guys are interested in the self-hosting community and you want to learn Kubernetes, this is a cool place to come hang out. So
was Kubernetes at home the community started by you originally?
There was a few people, Jeff Bilemek, I, and another Ryan, not this Ryan, but there's another Ryan out there who's also us three, and we had some other people come along the way as well. BJW, who's burned, and he has done a lot for helping people out, and also talking and chatting. So getting all these people involved in self-hosting is a very niche thing. Kubernetes is even more of a niche thing. So like in order to have that, you're taking layers of that down, and you're like, really, it's you don't really find that many people trying to do it. So yeah.
Yeah, and for well, actually, we should probably start with our personal setup. So I mentioned I've got these 3 nodes over here that I picked up on a university surplus, and they're 16 gigs of RAM. They're pretty simple. And then I've got a some big Xenon 64 gig thing that I just use for storage. It's just my storage device to provide the backend services for this. So what do your Homelabs setups look like? And maybe let's start with Ryan, actually, since and then we'll go to Davin.
Well, this is my home lab. I had the convenience of working at a data center, which gave me the luxury of achieving hardware people were going to throw out. So I figured I'm going to go full ham. Turns out I went half ham. I got the server rack. I only got 2 servers. So one of my servers is a compute host, and it has all the compute power, and the other is my storage server. And this rack actually started as an overt cluster, a single host overt cluster, which was kind of like Red Hat's competitor to VMware at the time. And it turned into Kubernetes when I started learning about Docker. And it's like, oh, Docker's pretty cool, but I'm getting really worn down with provisioning VMs and constantly making certificates and manually configuring the ingress, or we would call them reverse proxies before the ingress world in Kubernetes. And then I kind of came across Kubernetes and it's like, oh, this is the new hotness. This is pretty cool. And I started trying to do it in the home lab. And then a mentor of mine brought me into the Kubernetes at Home Discord, where everyone was doing all the things. It's like you hear about Docker and you get cool. And then you hear about Kubernetes and you think that's cool. And then you see the stuff people do to make this in their house. And it gets really crazy really quickly. So that's currently what my home lab is consisting of is, well, unfortunately, one dead server that I'm still working on and a compute server, but it's still a Kubernetes cluster. It's just a 1 node cluster. You don't need a big cluster to run Kubernetes. Yeah. You can do it on 1 node too, if you just want to get started.
Yeah. And Davin, your setup similar? Do you have a giant rack?
I have a 25 I have a 25U rack. It's not too big. A couple network switches. It's in my basement. Maybe I should have filmed in my basement today. I don't know. Gets pretty dark down there, even with the lighting. Yeah, I have 6 Intel NUCs, i3 and i5 variants, and they're split 3 masters, 3 control planes. And I also have a system like you for a NAS that's, my bulk media and, photos, backups, everything goes to that. Yep.
Yeah, a lot of my motivation for doing this, because when I first started doing this, I thought like, this is overkill, right? It's like how many nodes do I need? Because I have I'm currently at 8 nodes on my machine here, or on my cluster here, and it was like, why am I running all these nodes? And it was like, well, 90% of it, frankly, is just I just want to have, I'm in my role, so I'm an executive role, right? So I'm not hands-on with this stuff, and I just felt like I was going to get out of touch really quickly. So I wanted to do it in part just so that it's like I just want to keep my day-to-day experience going and make sure that I'm keeping my hands dirty and I'm keeping this going. Because just running, like if I was just going to run like Plex and stuff, like, it's not that hard to do on a single node, and redundancy is mostly it's about storage. So if I got a nice RAID and I've got some backups happening, and maybe I'm doing an offsite mirror every once in a while, that's pretty good. Was that the same? Is that the same motivation for most people, or for most people, is it really about the services that they need? And because you mentioned photo backup, you're not probably using Google Photos, you've moved that in-house.
I'm using both though. So I'm using this new call out there. It's called Image, but it's like alpha, so they tell you don't run it in production, like home production. But I'm also using Google Photos, so that hopefully can go away in the future once Image becomes more popular. But no, it's pretty much the same reason as you. It's like I'm into technology, and I also do this for my day job too. Like I'm an SRE, so like I need to keep the tools in my tool belt. I need to make them better. I need to work through problems and how to solve them. I can bring what I learned from home to work, and I can bring what I learn at work back to home as well. So like it's kind of like a very nice equilibrium in a sense.
Yeah, do you
But yeah,
do you have that experience where you're like, hey, we should deploy this into prod because I run it in my home lab and it's been working pretty well.
Yes, that has happened quite a few times where we'll test something out in our home lab, like say like certificate management, super mundane home lab thing, right? But it gets very important in the business. Things like that we can test at home. Kubernetes will just feel exactly the same like some of the clusters that we have at work, and it will be mostly applicable. Like, for example, one of the things we use is a GitOps tool called Flux, and we can take the lessons we've learned from managing our home clusters and apply that to our day jobs as well. So
yeah, it is
sharpening
nice
those
if it breaks in
tools.
your home lab before it breaks in production.
Yes, the home lab can handle that a lot easier most of the time.
yeah.
We have a question in the stream from DigiLink. They're asking, what's the opinion on running Kubernetes on VMs versus bare metal? They're currently doing a home lab on a 3-node Proxmox cluster. So they're doing the VM option. Any strong opinions about it?
I would go for bare metal, but there's if you know Proxmox and you know your way around VMs and you take the considerations of how to do storage, I think Proxmox can be fine in VMs. A lot of people try to deploy a 3-node master on a single Proxmox cluster, single node Proxmox cluster, and they might run into issues with etcd, all writing to the same disk at the same time, and flooding the IO. That's a problem that I've seen people talk about quite a bit. And then if you layer on Longhorn on top of that, you get more problems happening. You just got a lot of disk IO that's not available. But yeah, if you're comfortable with the DigiLink said he had a 3-node Proxmox cluster, so that seems like it works out fine. Stick with it.
Yeah, I run mine bare metal, and I started that way because when I started, I was using Atomic Pies. They have 2 gigs of RAM per node.
Yeah.
And it was like not gonna. I actually tried. I actually tried to see, like, I was like, how slim is this Proxmox? Like, how slow can it go? And that was not gonna work. And running a cluster that small, I very quickly realized, like, oh, Prometheus. I'm not gonna get that because that's gonna. I literally won't. I could maybe run Prometheus and not anything else. And it would just be Prometheus recording how well it's using all the resources across my nodes. So it's like that went out the window, and then like anything that required daemon sets, I was like, oh, that's not going on because I can't take advantage of my horizontal scalability to deal with that because I'll just be demolished off of that. So. I actually, I agree with you. I think it's like, hey, it's fine either way. Bare metal has some advantages for simplicity, and you're less likely to run into those backend IO issues. But I also think, like, I don't know, there's something fun about the challenge of trying to run slim, streamlined clusters that are super small and just take advantage of horizontal scalability. I think it teaches a lot about container memory management that I haven't felt in these expensive cloud environments where it's like, I don't know, just throw more memory at it, no problem.
Yeah, you go to drain a node and it moves workloads over to your 2 gigabyte, Atomic Pi or whatever, and you're like, that might need more.
Yeah.
But I also
somebody's in the chat is saying that they experienced the exact same Proxmox Longhorn high IO issue, which makes perfect sense.
Yeah.
If I was going to run my cluster on VMs again, specifically on a 1-node Proxmox cluster, I personally would just do a singular VM, because when you have a full-on Kubernetes deployment with 3 master nodes and X amount of workers on 1 node, you have the overload of VM management times whatever many nodes you have. Then you have your additional stuff on top for all the IO that's emulating on your same disk. And frankly, Kubernetes and pods, they take resources, but not nearly as much as virtualization does. And 1-node Kubernetes clusters are actually very viable in the home lab. So if you're going to run in a VM, you only really need 1, maybe 2 for the sake of failover. Have a dual master cluster and you'll be set. or maybe 3 master cluster actually, but having a full-fledged 3 master X worker cluster on one node's a bit much. That's a very taxing.
Have you seen anybody do bare metal auto scaling at home via like a Tinkerbell, like triggering a new node to boot up and then shut down later? Have you seen anybody do anything like that?
I've heard it discussed, but I've never seen anyone do it. That there's a lot of considerations there. But it can be done. Firing off a wake on LAN packet to turn on a node, then shutting it off and then turning it on again if you need those resources. There's probably some glue with all that. I don't know if Tinkerbell or even like Sidero from Talos would go that well, but yeah, I'd like to see it.
Yeah, it's something that I have is like in the back of my head to accomplish at some point, and I didn't want to do it. It's like tricky because it's like, well, I'm gonna get into NetBoot, right? And then do I want to run it? Do I want to run an update so it's on, or do I want to keep it in memory because that's going to take more memory? And so then it was like, well, I've got these 2 gig nodes. That's why I ended up getting these 16 gig nodes, because I can actually do stuff with them. So I think it'd be really cool to do at some point and have it like automatically spin up and spin down, especially because like if I want to do like library management where I'm like, oh, like I want you to go transcode all this stuff into new formats, suddenly spin up all these nodes, shut them all down, get the power savings. I feel like that would be the ultimate coolness, but it's not necessarily practical in the home lab. It feels like a lot of home lab stuff, it feels like maybe overkill.
That sounds like a really cool idea. Like I've said, I thought about it. I've seen people talk about it, and someday maybe there's an easier way to do it. It doesn't seem like maybe that's existing today.
Booty Man
If I
Jojo
definitely had
says-
some IPMI. Oh, go ahead. Sorry.
No, finish your thought.
I was going to say, if our nodes had IPMI, most of our stuff is just cobbled together stuff. That would work really well. Things like Talos and other node, even Proxmox, I believe, they all work on IPMI. You could add it in with a Pi card, but it's very hard to do when you just have a bunch of Intel NUCs. Yeah, like IKVMs, or if you have server enterprise, you'd use that. But most of those use that, and when it comes to not having those, it gets into this really awkward territory where you have to rely on a lot of glue.
You could build just a little relay module that just shuts off and shuts on power. I'm sure that's really good for machines. Maybe that'll be a chaos engineering project. To take out
a little bit of trouble, yeah.
Booty Man Jojo says right now he can't even run, or they can't even get a cluster with a 2 gig node to run. They tried with a single node 2 gig Raspberry Pi 4 and it failed to be up. I wonder if he's using K3s. Is everybody using K3s? Or I would assume, because K3s is so slim, which is why I chose it, and I have a really easy time using it. But would you say that's the most popular distribution people are using?
It's split. K3s and Talos are kind of the most popular in our Discord amongst everyone there. Talos is by definition probably the lightest I can think of. Like it's like 100 megabytes.
Oh wow.
120 megabytes. It just as the ISO, and yeah, it's immutable. It's pretty neat. It's a pretty neat tool. There's some challenges with it, but overall, it's really cool.
And I haven't used it. Does it have the same? Because K3s has like version manager you can install, so you can actually have it upgrade its own nodes and stuff, and you can do it declaratively. Does Talos have something similar?
Yep. So Talos is all API driven. Like you don't even have SSH access. So there's a Talos CTL command, and it's your interface with the cluster, with the nodes.
Oh, interesting.
Yeah, Talos is the entire operating system. So when you think of running K3s in your cluster, your first question is going to be, what operating system do I run it on? Ubuntu, Fedora, XYZ. With Talos, the answer is Talos. Talos is literally a whole operating system, and you configure it with this one text file. So that's why it's very popular in the home lab space, is because you take that whole operating system environment of managing your OS updates, configuring your operating system for Kubernetes, and then Kubernetes, and you shrink it down to the OS that runs Kubernetes. And That's really nice. You can do that on things like Raspberry Pis too. I don't know. I haven't run it on ARM personally, but I imagine it's pretty simple overall and very similar to x86 hardware.
And can I get GPU access and the drivers and stuff? So I was at one. I'm actually not at this moment, but I was running Plex on my Kubernetes cluster. I didn't. It takes a little long to spin up a new pod to do additional stream, and so I wanted to tune it more. But GPU access, that Talos, no problem.
Yep. What are you using for your GPU?
Well, on the Atomic Pis, it's actually just installing the Intel. Oh man, I'm trying to remember what it is. The Intel extensions that allow you to basically access the transcoding components that are built into the CPUs. It's like something that's part of the Cherry Lake CPUs. On these ones, I haven't I was actually planning to at some point install some probably NVIDIA cards or maybe some AMD cards, depending on. I wanted to do some 4K transcoding, but to do that, I also need to upgrade my storage link to my storage backend because I'm not going to get enough bandwidth to really do it.
As Bob Ryder said, yeah, with Talos, the Intel GPU is pretty much it's a default loaded kernel module, so it should just work out of the box. For GPU, for like external GPU or NVIDIA, Talos has docs on how to hopefully get that working.
Oh yeah, somebody's saying Intel GPU plugin. That's what I was trying to think of, and Intel QuickSync. That's what I was going for.
Yeah, I feel like that's probably the best way to go. I feel like having an NVIDIA card is a little bit overkill, especially if you get like 3 of the same nodes and they all can do transcoding. Then you can just have Plex fail over to another node if you need to take it offline or something. So
yeah, have you seen people do some beefy networking storage solutions for this stuff? Because the one part that I feel is a bummer about my setup is I would love for it to be pure Kubernetes, but I've got this node over here that's just running all my storage, and you can do distributed storage, and Longhorn can help you, is really more about replication and maybe like I use Longhorn to handle database stuff because it works really well for that. It's not trying to do writes over network, but and then it propagates and stuff. But have you seen some awesome storage solutions that people have done, and any Kubernetes native ones, or is it always Kubernetes plus non-Kubernetes storage?
Well, for me, it's Kubernetes and then non-Kubernetes storage. But I have seen people do like an all-in-one thing. one of my colleagues does pretty much Ceph and I think it's like Fedora on one big beefy server with all the nodes and the NAS and everything. So that was an interesting. I saw that and I was like, that's pretty interesting. But for me, I kind of like the separation of concern, separation of systems. Like I don't want my Kubernetes cluster to go down and lose all my media or lose all my photos and stuff like that. So I kind of treat it as like a pet. It's just sitting there, it's doing stuff. Hopefully I never have to touch it. It works.
Yeah, same story, Ryan. Any divergence?
So yeah, because this cluster originally came from a traditional VM setup, the top node here, which you might be able to see a little bit, does all the thinking. And this bottom node here is purely a CentOS NAS. And it needs to get redone. But essentially, Kubernetes is only connecting to it over NFS. I don't have single node Kubernetes is kind of weird when it comes to storage. So for me, it exclusively is Kubernetes and then storage kind of equation. If you have, like 5, 6 nodes like you do, you could then use like a spare disk in every node to have an integrated storage where, it's replicated and you can use it for your database stuff. But for things like bulk data, like movies, big files, photos, I use the storage NAS just so that, hey, if my main node dies, I still have access to that kind of important stuff. And, that's kind of what backups are for, but it's also just kind of it's just so much data. It's hard to fit terabytes and terabytes of anything onto one node without it being specifically built for that. And then you run into this territory of, well, do I make a really big server with really big storage and then have a bunch of them, which kind of gets expensive for like a home person? Or do I just like have this one big beefy storage node that's all it does, and then you can have smaller compute nodes that access that storage?
Yeah, I kind of wish that I could have something like a distributed RAID setup where I could lose 30 or 40% of my nodes and I would maintain storage, but I could do like, 40 terabytes across these nodes. And so I would still get kind of that RAID 5 experience. But I don't think there's anything really like that. And it would be kind of cool if it would also sort of take advantage of the networking being distributed to be like, oh, I need to fetch a file. I'm actually going to fetch it from like 3 nodes and I'm going to get better networking performance that way. But it doesn't seem like anything like that really exists.
You you could use a 3-node Proxmox cluster with Ceph on it, and then have Rook running in your Kubernetes cluster and attached to that. That kind and Ceph supports NFS, it supports block store, it supports file system, and it supports S3 too. But again, that if your cluster goes offline, you better be prepared to.
I lose my storage.
Or not just lose it, but maybe you might have to take some time and learn how to fix it. Like that's Ceph is a pretty big piece of software, so it's not completely straightforward.
I like started to investigate it when I was deciding to go with Longhorn, and Longhorn was so easy that I was like in halfway through my investigation, I literally just stopped reading any Ceph documentation, and it did feel like maybe that was more an advanced path to take to do something, nuts like what I wanted to do.
Yeah.
Let's see. So the other thing the other topic I was gonna broach here is the GitOps aspect of it, and because it is GitOps the Planet. And I use Argo CD to manage my cluster, and I use it professionally. I'm a maintainer of Argo, and so one of the things that actually I didn't mention this to you, but one of the things that actually drove me to reach out to have you on the show is because I was talking to a customer, a CodeFresh customer, and they were talking about their interest in Flux. And I said, oh, well, what makes you pick Flux? What attracts you to Flux over Argo CD? As a maintainer, I'm interested. Like, I want to know if there's more features we should be building or something like that. Maybe we can do it. And he said, well, I'm part of Kubernetes at home. And he said it in such a way that was like, so yeah. And I was like, what the hell does that mean? Like, I'm in that Discord too, albeit not nearly that active, to apologies all around. But he was like, no, I'm part of Kubernetes at home, so I use Flux. So what is that? Like, why is that? What's the is it just like, is it like 90% of the Kubernetes at home that's using Flux, or is it 50-50, or what's the breakdown? And then I know that a lot of the tools and the resources you guys provide are Flux oriented. So I want to hear about that choice too. So maybe we could start with kind of the breakdown and then how that developed.
So it goes back to kind of like the origin of the Discord server, which was discovering a repo that was doing this with Flux, Flux U1 at the time, and just sticking with it.
This was Bill Meck's repo.
Yep.
His OG repo was using Flux.
Yep. And just seeing how the pieces connected there. It's all in code. There was no UI, so it's just CLI commands and straight YAML. So that just made me as a tinkerer just play with it more. I don't know what Argo was like back in 2017, 2018 time, but Flux seemed to just like work. I don't know. But pretty much the breakdown, a lot of people in our community do use Flux, but there's also a lot of people that use Argo. I would say more people use Flux because there's a project that I maintain that I created called the Flux template repo. And that's like an A through Z walkthrough of getting a Flux cluster up and running using K3s. And like it's opinionated, which some people like, some people don't like. But if you follow it through, you would get like a pretty nice stable cluster, and you start tinkering with it right away.
Do you actually want to take a minute, maybe share your screen and show that off and like walk us through it?
Sure.
if that's not weird.
That's fine.
Oh yeah, I like in the chat while you're pulling it up, some chat people are saying, I had my Ceph cluster die a few months ago, still working on trying to figure out how to get it back.
Yeah, the fun thing about things like Ceph is it's very powerful, complicated software, right? And the moment something breaks, you have all that complexity to digest. So it's kind of those caveats, right?
Powerful, but dangerous.
Yes.
So a little bit before I go into this, I would like to see this type of setup for Argo. Exactly kind of what I'm going to describe here. But basically this repo, it's a guide. The whole README is just a guide to follow, and it uses Ansible, Terraform, Flux, the secrets operator from Mozilla, SOPs, GitHub Actions, and Renovate. And that's another thing we can get into later. But it's basically a single bash file that templates out a bunch of files for you. You fill in the configuration, you run configure, templates out a bunch of things for you. But yeah, it's a lot of components come with it. We get Flux, we get kubevip, MetalLB, Cert Manager, Calico for the CNI, external DNS. So this will actually provision your DNS records on Cloudflare for you.
Oh, nice.
We're using the external DNS operator. Same thing for SSL with Cert Manager. There's a tool called K8s Gateway, which is a DNS server that runs inside your cluster. And that gives you direct access on your workstation to your ingress. So you can, anytime you go to plex.yourdomain.com, it would route through the K8s Gateway instead of going, outside the internet, coming back. So it's kind of like a split DNS type of thing, but it's a DNS server that runs in your cluster, is aware of the ingresses, and can make DNS records for them. So it's a pretty neat thing.
Yeah, that's really cool.
I use a Ingress Engine X here, and just for storage, it's local path provisioner. Storage, trying to tie like Longhorn or Rook into here is a little bit more complicated and requires a little bit more. It's a little bit more opinionated on people's setups and how they've customized things. But the main setup is you install a bunch of CLI tools, and there's a bunch, and you set up age, which is something you use with SOPs, so you can commit your secrets directly to your repo and they're encrypted. So Flux can decrypt SOP secrets for you before it applies a customization.
Oh, okay.
So you can put these variables, you can put variables in any of your YAML files. And when Flux goes to template it, it will do a swap. It will do like an env substitute and swap them out. So that's a really neat feature, but that's a Flux. So anyways, you create that, you get your Cloudflare API key, and then you start filling out some configuration, run through some Ansible steps. So first you have to install Ubuntu or Fedora server on your nodes, and then you run some Ansible tasks, which is
and
the operating. What's that?
You've chosen K3s on this.
Yes, so this one is K3s, right? Yep. Yeah. So Ansible Prepare will basically wire up, do some plumbing on the nodes for you, set host names, copy your SSH keys if you need them, and a bunch of other stuff. And then again, using Ansible this time to install K3s. And if you all go through it fine, you should see that you have a cluster up and running. And then the next part is Terraform, and that wires up your home IP address as an A record in Cloudflare. So that sets that part up for you. And then the next part, which is installing Flux, and it's just one command for that, push your changes, and then install it, and then just verify.
Oh wait, so it installs it, but then it also generates commits locally. Oh, because Flux generates that when you're installing it, and then you just push it manually. It doesn't push automatically.
Right. So that configure script I was talking about before, it templates a bunch of stuff out to you in your repo directory, and then you're just committing that stuff back up to Git. And then when you install Flux, it's going to read your repo and then apply everything for you.
Gotcha. Okay.
That's included. And then just some verification steps, and long-winded post-installation things, which, where I explain how you could set up an environment, how DNS works, whether it's internal or external, how SSL works with Cert Manager, how to get Renovate bot running, how to get Flux to reconcile changes on a push instead of a pull-based model. And then I just talk about some other things like, what could you do with storage? There's a bunch of options.
I mean, this is an awesome resource. I mean, you've put a ton of work into this. How many contributors are on this repo?
Let's see. We got about 48.
Wow. So. That's cool. And does Renovate, so I've seen Renovate being used for like language dependency management, like, oh, you have a new Go module available. Does it also work for Kubernetes, like Helm charts? Like, hey, there's a new version of this Helm chart available, or there's a new version of this customization available. Does that part work too?
Yep. It supports Flux resources. It also supports Argo resources too. It supports, say you have Ansible and you have a requirements that's pulling in external dependencies, it'll work on that. It'll work on a bunch of things. Like it's a pretty neat tool. But yeah, so it'll open PRs for you. We'll come across these dependencies, open PRs for you, and then you can review them and you can check the change log if you want to before you apply it. And then when you merge it, Flux is, obviously listening to your Git repo, and then it's gonna make those changes for you.
So it's interesting because I did notice the one thing that I saw in there that I was like, oh, I wonder how I would do that with Argo CD was the rendering secrets into the manifest. And that's not something that you would normally do with Argo CD, because Argo CD does all of its manifest rendering absent the cluster. And this is something we did for security reasons. I mean, it's we viewed it as a when you give somebody the ability to generate manifests with Helm or with JSON, which is like a full-blown programming language, and you run that against the server, there's the potential that people could try to access secrets or access things they're not supposed to access. And there was some anxiousness about that. And so that was one thing where we wanted to separate it within Argo. And then the other thing within Argo is for diffing sake. And this is something that I think Flux handles pretty differently than Argo. Argo CD, you can say like, oh, ignore differences on this field because I have another controller that, is deciding how many replicas there are. I don't want to commit that to Git. But my understanding is that it doesn't work quite like that in Flux.
Ryan, do you want to talk a little about that?
So I used Argo before I switched over to Flux. So I have a little bit of view of both of the worlds. And if I wanted to replicate the ability of having your secrets in some sort of encrypted fashion with an Argo cluster, I at the time was using the HashiCorp provided CSI that would take secrets from your key value store in HashiCorp Vault and do it. I'd actually recommend doing that now with external secrets. So instead of embedding them directly into your manifest using this markup that only Flux would understand.
Yeah, it would just the way that I would do it today.
Yeah, that's how I would recommend it too. You're doing Argo. I didn't use too much of Argo's diff understanding and ignoring, and I don't use that too much in Flux now, so I don't know exactly how those are different, but Argo does have the ability to, you can get really down into the keys, and the UI for Argo is great, and you can do a lot of really cool things with Argo, and they do roughly the same thing most of the time. It's just the Flux also just kind of came up is that, you don't have the nice thing about Argo, and the part that I really liked about Argo is when I was learning GitOps, I was able to use the UI for configuring my application and figuring out my projects and attaching clusters to it. In Flux, you don't have any of that as a luxury. You have to figure out either the manifest CI or the CRDs for it, or you don't, right? And on Argo, you have both the option of the CRD and the UI to do it. So if you want to sit there and go through the UI and say, I want to ignore this specific field on this application, you can do that very easily in Argo. But with Flux, you have to figure out the CRDs for it, which Either way works, really. It just kind of depends on your work style. One-off things you may not really want to sit down and learn the CRDs for it. In Argo, you can go through that whole process really quickly. Repeating it, though, becomes a whole nother story where you want to use Argo's CRDs available to it.
Yeah, the one of the things that when I did an evaluation of Flux, and I was already working on Argo at this time, but I did an evaluation of Flux because I wanted to understand it better. And I really liked the CLI experience, and I liked how it staged commits, and it kind of helped organize my repository. And I liked a lot of stuff about it that felt like, oh, this feels like it was really well thought out. It feels like somebody really took the time to think about a lot of the defaults. Whereas at the time with Argo, it's very flexible, and it's like, hey, you get a UI up and running, you go and click, and you're getting stuff deployed, and you can kind of go different directions if you want. So we actually created this thing called Argo CD Autopilot, which is an Argo Labs project, and it's a CLI, and it will bootstrap your repository. You can, if you add an application, it will actually commit it to Git, and it'll actually basically operate as a Git client for all operations. Because one of the things that people do get in trouble with in Argo CD sometimes is they get into the UI, they start deploying stuff, and they're like, hey man, I'm rocking and rolling, I deployed an app, I deployed that app, and then pretty soon they've done a whole bunch of work, and then they have never actually committed it to Git. So even though the source of the application is in Git, the application policy itself isn't in Git. So Argo CD Autopilot solves that. And then in CodeFresh, we have a UI that actually commits it to Git. So you would use that instead. But that is one area where I do see people sometimes getting themselves into trouble with Argo. And it is nice it feels like in Flux, that part of it at least is easier. Or at least you're less likely to get yourself in trouble. Let's put it that way.
Right.
Yep.
The bootstrapping in Flux is very well documented on how you can do it. And Argo, in order for me to replicate kind of Flux's encapsulation of the bootstrapping and encapsulating itself in its own configuration, what I did in Argo at the time was I had a Helm manifest of Argo, and inside of this, it was a charted chart. I had my chart that had the Argo chart as a dependency, and in my chart that contained the chart, I had a template, and that template contained the Argo's own application manifest and Argo's own configuration. And that, kind of this idea we like to have in Homelab is that we just literally run one command and the whole cluster's back up like if nothing happened.
Yeah.
And that gets you to the point where Argo spins itself up, it configures the projects for you, it automatically attaches the local cluster and gives it a name. And then I even had mine with an application that pointed to another folder that had my application sets, which pulled in the rest of my applications of like actually Plex and all the things I would actually run. And that's
so wait, this is the way you
get.
set it up yourself, was with that Helm chart.
Right. Early last year, I was fully on Argo, and that's how I was trying to switch away from using the UI, right? Because I got very comfortable with using the UI. I understood Argo's primitives of projects and applications and clusters, and started getting a good handle on application sets. And then I had to sit there and think, well, how do I go from having my application sets being ingested so that I could just deploy Argo and it pulls in everything? And you kind of end up with this weird scenario where you're deploying Argo with its already included self-references, and then you can deploy your application sets from an application, and then it just cascades down from there.
Actually, I want to talk about application sets some more. Before we do, there's like in the chat, there's been a whole troubleshooting session on Ceph going on, and people are figuring out how to recover this guy's cluster. So good work, chat. And then Shock asks, Davin, is your project comes from professional experience or the other way around? And it sounded to me like you were saying, I was doing this at work and then I came and did this at home. But then it's also doing it at home. I'm helping me at work. Yeah,
exactly. It's both. It's most of my knowledge probably came from home, bringing it to work. But I've also learned a lot at work. So it's like, I can't really give you, it's not an even split, but it's pretty close. For
I mean,
example,
it makes sense. We take more risks at home, on our
Right.
home labs than we would take at work.
Right. Like I really need to get caught up. I really needed to get caught up with external secrets. And so I'm using that now in my cluster as well as SOPs as well with Flux. So I'm using both. SOPs is more for bootstrapping because you need secrets in place before external secrets can be deployed. It's chicken egg scenario. So just having that integration with the Flux, saying like, you can use this integration, maybe you only need a few secrets, but that gets you to the point where you can pull in all your other secrets and so on and so forth. But yeah, so learning that project, I did a lot of it at home, and then we started using it at work. And I think we were using it at work, but I needed to learn up on it more. So, pulled it into my home lab and started tinkering with it.
Well, this is actually a good pullback into the application sets thing that I wanted to talk about, because I'm curious about how you'd handle these different scenarios in Flux. So with application sets, and for those that are unaware, I mean, because I think we have a lot of Flux users who maybe never used Argo CD. Argo has the concept of an application, and an application is basically a policy that it says, this is my application. I want it deployed to here. This is the source of truth for that application. And I have a sync policy that says, if something changes in production, automatically overwrite that change. That's called self-healing true. That's a sync option. Or I can also have sync options that are like ignore differences on certain fields. So don't trigger synchronization if my number of replicas change. That's supposed to happen. Don't worry about it. I don't care. Or like if this job changes to complete, don't like automatically resync the job or something. So you have this, that's the concept of an application. The concept of an application set is that you can generate applications. And we have in Argo CD, we have generators for clusters. So for example, for all of the clusters that an Argo CD instance is managing, it can automatically generate a cluster, an application for each cluster. And so these are meta resources that are automatically generated. You can also do things like a pull request generator. So anytime someone opens a pull request, I can have that automatically generate applications. I can do it on a folder structure. I can do it, which is how Argo CD Autopilot works. I can do it based on every Git provider. There are dozens of these generators that you can use for different scenarios. And I think if my understanding of Flux is correct, the way that you would handle a lot of those scenarios is through some kind of external automation, like maybe a CI/CD pipeline that would generate a pull request, for example. On a pull request, run a pipeline that generates resources and triggers action or commits changes. Is that right? Or is there some other better way to do it?
Ryan, maybe you can correct me if I'm wrong, but it's with Flux, we have these CRD types of Git repository. And that CRD is the ref to the GitHub or GitLab or Git URL, the tag it's on. And then you can also say deploy from a folder from within that Git repo. So I think that's kind of what you're talking about a little bit. And then you have a customization, a Flux customization underneath that, and that deploys the resources from that Git repository, custom resource. I think that's kind of like what an application, does that sound familiar? Like, I don't know, Ryan, if maybe.
Sort of. So to compare with the Argo world, in the Argo world, a application, it can be a generator like a Helm. So it's kind of like Flux's CRD for Helm. Or you can do a direct path of a raw Flux manifest. And then what I've seen a lot of people do when I was doing Argo at the time was we would create a chart that had the dependency of the chart we wanted. This gave us an extra layer to add in any custom things we wanted to do. So let's say we had an application that consisted of multiple subcharts. Then we could take those subcharts, and now they exist as just another key under the main values.yaml file. And you can then populate that YAML file. And if you were doing, say, an application that was based on a globbed path that pulled up a JSON file, you could have this JSON file reference, hey, here are my multiple entries for this path. The path is here. The name is this. This is like this meta information. This is other YAML files you would pull. So in the Flux world, let's say you wanted to run a multi-cluster environment. Say you had a cloud and a home cluster. The way you would deploy the same manifest in Flux is you would have a base manifest of just what you would expect to be populated.
A customization based manifest.
Right.
Yeah.
That's that's what Flux uses at the end of the day. It's all customizations and just normal Kubernetes manifest underneath their two custom resources. That is just a Git. So you can pull from a Git repository. You can pull from an OCI repository, which is becoming a new thing in our world here. It's taking slowly gaining adoption. And you can do a bucket too. Like you can deploy code straight from a bucket. It has a support for all those, and then underneath that, you just need that Flux customization with your bases and your overlays. So
with the OCI registry, and this is, by the way, a lot of fun for me, and I really appreciate it. It's like market research for me. I want to understand these differences, and if there's stuff that we should be building in Argo, I want to build that stuff. The OCI registry thing, I think the way that I read this and understood it was basically in Flux, you can say, deploy the latest version of an image, for example, and it will use that as a source of truth. Is that right? Is that how the OCI registry works with for Docker images or for Helm charts?
So OCI, in the way that I'm thinking about it, at the end of the day, it's just manifests that are in a Docker image, nothing else, just YAML files.
Okay. So it's actually wrapping the manifests into an artifact and not relying on like a Docker image changing or a Helm chart changing necessarily.
Right, and you can version that. Yeah. You can version that. You can co-sign it. It's another brilliant feature of it. And then you can just use Flux to say, hey, from this OCI repository, deploy this thing that's in this path, and then here's your your customization overlays if you need them.
Is the advantage of pushing your Kubernetes manifests to a repository like an OCI registry? Is it just more granular control and then the security implication of being able to co-sign it and verify these versus like if I pointed at a Git repo and I'm like, oh, take this release, like I manually create releases or maybe I automatically create releases. What's the advantage of pushing it to the OCI registry?
So a couple of advantages I can think of are there's less overhead with OCI. You don't have to clone a repo. It's just Docker pull, or under the hood, quote unquote, OCI pull, Docker pull, whatever thing you're using. But I think the better feature is, I was just thinking about it. Oh my God, it came out of my mind. You don't have to deploy a Helm registry, for example. Like you could just use your existing Docker registry, whether it's Nexus, Harbor, whatever, and just deploy your OCI artifacts there, version them, use Flux to pull them down and use them. I know Argo supports that part, like Helm OCI charts. I don't think it does. I don't think it does support regular OCI, like an OCI image with just customizations in it, for example. I don't know.
Yeah, I guess the way that you would probably do it is by having a customize that pulls in the version of the OCI resources, I guess. But it would still be based on Git, I think. I'd have to look. I haven't seen that as a feature, and it's not something I have looked at before. Because I actually thought it was about using which Docker image is currently up there as a potential source of truth, which is something that with Argo we do with we have this tool called Image Updater, and you can say deploy these manifests, but as part of my application policy, deploy images. The latest image based on this semver or just the latest one deployed. So you can say deploy the latest version 3 image, and then every time one is pushed, it'll just automatically update it. Which I think that's obviously different than what you're talking about. Is that if you were going to do that with Flux, would that be a customization thing that you would do? I don't know how
Flux also has concepts of the image automation. They have an image automation controller, which is another custom resource that can do OCI. It can do normal application images as well. So yeah, both seems kind of similar, except I think Flux has that OCI component that you can pull in just manifest with.
For the Flux side, they also recently just came out with a UI. Have you guys tried that out? Have you had a chance to review it?
I've tinkered with it a little bit. It's pretty basic right now, but we'll see in the future. Hopefully they get get it better. Like you can do simple things like sync, suspend, resume resources. You can see kind of like a chart of what's going on. Yeah, that's pretty much the functionality of it now. You can hook it up to OAuth. I'm probably not the best to give a review of it, but it's getting there. It seems like they want to have that integration as well with their platform.
Interesting. Yeah, it's pretty cool. I've been impressed with the work that Flux is doing, and one thing that I noticed with Helm, for example. So I started tinkering around with some folks on potentially improving some of the native Helm support in Argo CD, and don't get your hopes up on the stream. I haven't made that much progress on this, but the kind of advantage, what it felt like between Argo and Flux on that was with if I'm using a Helm chart and I have Helm hooks, most Helm hooks are supported within Argo CD, but because it's not doing server-side rendering, you can't do value lookups, which is something that's not supported in Argo CD. And again, in part because it's a security issue, right? That was part of the reasoning in the first place. So that if you want to do those kind of value lookups, Flux does that because they have this Helm controller that is running server side and it can do those value lookups. So that's an advantage for Flux. But on the other side of it, diffing seems like it's maybe better in Argo CD because I can say ignore these fields or ignore these components. Whereas in Flux, I think it's like you need to commit those things. And so I was thinking about it in terms of like Kyverno. So Kyverno is a competitor to Open Policy Agent, and I'm sure you guys are already familiar with it for those that are listening. And you can have a policy that does something like check for cosign signatures and reject stuff that doesn't have the signature. And Kyverno actually modifies the resources on Kubernetes. It actually updates the manifests to inject information. And so in Argo CD, I just added ignore differences. I actually don't know. I'm sure there's a workaround for how you do it with Flux so that it can handle that right information.
So Flux, as of today, doesn't support diffing Helm release. Like you can't say, here's the current Helm release, that version, and here's the version I want it to go to, and get a true diff. You can diff their Flux customization resources, but Helm charts, they're working on this. I think probably by next year, hopefully. Like they recently published a roadmap, and they had some things related to it about their Helm controller and making it more resilient and making it a little bit better. So I'm hoping once that stuff gets done, they'll have some development time to actually like do that. What I'm currently doing now to gain that support is I have a GitHub action workflow that I wrote, and basically what it does is I wrote it. It was adopted from other people. Like this is the thing about K8s at Home is like everyone in the community shares with each other. So this was originally a thought of an idea. I think I don't remember who the member was, and I'm sorry if you're watching this and it was you. But yeah, I took what they did there and I expanded on it a little bit. So I made basically what happens is when a PR comes in from Renovate and it's a new Helm version, it will do a Helm pull on that chart. It will extract the values out of the Flux Helm release and then do a diff on them and post them back as a comment to the PR.
Ah, smart.
It's a static check, so you're not going to see exactly 100% what's changed because it's not, taking one for one, what's deployed in your cluster and what's, you want to pull in. But it's pretty neat.
Okay. Yeah.
There we go.
Yeah.
Someone wrote, it's not stealing, it's unexpected collaboration.
Sounds like non-consensual collaboration if it's stealing. But yeah, unexpected collaboration. That's great. Unexpected. That's great.
But on that topic of collaboration, another nice thing we have with using Flux in our community anyway is we have a website you can go to and you can search through everyone's deployments who's put a specific topic on their GitHub page, on their GitHub repo. So you can go through and you can say, oh, I wonder what, Grafana values Ryan's using or Davin's using. And you can go and look at those values and you don't have to you can go and still look upstream to see what the source is, but these Helm charts are they can be pretty overwhelming at some points. Like Prometheus stack, easily like 1,000-line value file to sift through. Where if you're running K3s and you want to look at Kubernetes stacks, someone else is using K3s, you can steal my values, you can steal someone else's values. Unexpected collaboration. So yeah, there's a website. You can just type in the name of, type in Frigate, which is a video camming, streaming, recording for self-hosted folks. And you can see, oh, how does this person have their configuration, their config map configured? And, poke ideas from there, look around. Yeah, it's pretty neat. That's probably still useful for Argo too, though, because you're just looking at Helm values at the end of the day, I think. So,
Yeah, it's something.
Yeah, the nice thing.
Oh, go ahead.
The nice thing about Argo values is that you don't have to do the mental math of taking the CRDs and then translating it to Helm values. With Argo, and you're doing your application manifest of a raw Helm repo, you just yank and paste your values as is. You may need to go over one key level, but that's the nice thing about Argo, is that if you see values out there that you really like, you can just copy and paste them. With Flux, you have to keep in mind that CRD, and you have to adjust for that. It's not a lot, but it's just a little bit.
Yeah. Well, yeah, that it's something that I'm kind of related, but with Helm, I'm anxious oftentimes about the way that the charts are constructed, because if I think about what Helm values should do, like ideally, it's like switch off a bunch of functionality. Whereas when I look at, and this is probably why Helm file has become more popular, most of the time it's like we just have a bunch of manifests where every single value is a value, every single possible parameter is a value. And now I have a values file that's like, what do I need the manifest for? I have 2,000 value switches to deal with. And so that's one of the things I appreciate about a customize is I'm like, look, I just want to overwrite this one value, man. I don't know what's going on in here. I don't want to get involved. I just want to update. I just want to change this thing to a load balancer, IP and not a node port. I don't want to have to go modify the chart. I can just do this with a simple customization. So I've actually started and this might be an anti-pattern, I don't know, but I've actually started most of the time that I use Helm, I actually use customize to ingest the chart and then overwrite values, just so I don't have to go and learn the chart, because I don't want to learn how to update the values in the chart. I just want to do an override. So I don't know if that's an anti-pattern.
A little bit, but that's okay. At the end of the day, it's like with whatever you're comfortable with. There's I want to plug another little project that we have. Please. One of our community members, Burned, BJW-S, he wrote pretty much by himself with the help of a few people, also a app template Helm chart. So say you have a lot of self-hook. Yeah, so it's basically a Helm chart where you can plug in some values like the image, the service port, and some persistence, and just deploy any application you want.
I was joking about, like, I was seriously joking about somebody making that the other day on Twitter. I was like, how long until somebody just makes a chart it's just works for every application, because that's what all the values are anyway. And it sounds like it's happened.
It works very good for applications that have very minute configuration, but it can still get pretty advanced. Like for simple things like Frigate or Home Assistant or Plex, it works great. When you start going into like, do you want four containers running in this pod? Get a little hairy, but it's doable. I think at the most in my repo, I think I have one that has like 3 sidecards to the main pod. But what I do is I just put that in I put the additional containers block in a separate file, and I patch it in with customize. So it makes it a little bit easier to read. Yeah, it's a really cool project. That we used to have our own K8s at Home Helm charts. Like we used to support a lot of applications.
Yeah, that was a big deal when you guys shut down the Helm repository that you had.
Yeah, the main reason there was a lot of these applications, 80, 90% of them were literally just image change, tag change on the image, port difference, and some persistence, or maybe some environment variables. And that was the only difference between, we had 120 or so charts, like between all of those. Like it just seemed like supporting like that app template idea seems a little bit better for those, for these type of applications, I would say.
On that actually note, do you still feel like Docker Swarm is sort of the default for Homelab? Because like when I look up images and things like that, I find like Linux Server IO maintains a lot of images, and almost all of them are set up for Docker Swarm. And so I'll find myself taking their image and then writing a bunch of YAML to deploy it into Kubernetes and making some tweaks so that I can support it. Do you think that will that remain? Do you think it is the case that Docker Swarm is sort of the default for Homelab? And B, do you think that'll change?
I think more Docker Compose is probably, Docker Compose I think is just in general.
Sorry, I meant Docker Compose, Docker Swarm, Docker Compose. But some people also use Docker Swarm, so it's I think the most popular in Homelab and self-hosting is Docker Compose, and it works fine for people. I don't know if people are willing to switch over to Kubernetes until it gets a little bit more streamlined, and that's kind of, it's up to the maintainers of Kubernetes to help out with that, with all these applications, to make them easier for people to use. Not everyone wants to use the CLI. But yeah, Ryan, go on and expand on that if you want.
Yeah, Docker Compose is absolutely fantastic when you have one node and you have things like traffic that can ingest those Docker Compose labels. And it frankly gets you 90% of the way there of what we're doing in Kubernetes. The difference is that we're taking advantage of a lot more operators. Like, for example, we make an ingress. Not only do we get our certificate for it, we get our public DNS automatically adjusted for it. And I don't know if that's something you can do reasonably in Docker Compose, honestly. I don't know if there's a Docker version of that. So that's only a Kubernetes thing. And when you get to the point where you have things like the app template, where normally you would have to make this whole, you have to make your deployment, you have to make your service, ingress. It's all just turns into 5 lines of code. And you get all of those benefits of that automation. It's really nice to have. But when you're someone that's kind of learning in a home ops environment and you start with Docker, because, Docker is the big thing that a lot of people start in containerization, and you naturally go into Docker Compose. That's a really easy thing to learn. It's a YAML file. Everyone has a Docker Compose file that you can copy, change 2 variables in your set. With Kubernetes right now, you reach so many layers of abstraction that it's much more difficult to wrap your mind around it. And even worse, the moment something breaks and you don't understand those abstractions yet, turns into a very intense troubleshooting method where you're trying to figure out, was it my external DNS not reading this pod and this namespace? And those don't exist in Docker Compose in the same way. They kind of do, but not nearly as enterprisey focused as Kubernetes is.
Yeah, some of the problems still crossed over though, like file permissions. Like you go to deploy Nextcloud and it can't read your permission. The application can't write to your NFS share for some reason. You're probably going to still see that with Docker Compose, but some things cross over a little bit. But that's one of the other issues. Like so many of them, and I hope it gets easier in the future.
Going along with what Watt was saying in the chat about the bar to entry, I feel like, and maybe this analogy won't translate for everybody, but I feel like it's like skiing versus snowboarding. Snowboarding is really hard to start, but it's actually easier to get like pretty good. Whereas skiing is really easy to start and it's actually harder to get really good. So like skiing is like Docker Compose, where it's like, hey man, you're on the hill, you're doing pizza, you're having a great time, you're rocking and rolling. And like the person trying to install Kubernetes is over there just like eating it on their face over and over again. Like, what the heck? I got to set up storage. Like, I have multiple nodes I have to worry about. Like, I have like replicas to deal with. Like, I got to mount volumes. I'm not just doing these local volume mounts that are so easy. But then when you're like, when you're actually like scaling up, doing more nodes, doing those kinds of things, it's a lot easier with Kubernetes. I suspect that with Homelabs, oftentimes people don't care that much about multiple nodes. So I'm curious, if that will change, but yeah, it'll be interesting to see. We'll have to see if Kubernetes keeps getting easier. And I mean, honestly, projects like yours make it a million times easier for folks. And that's why I'm so anxious about your choice of Flux, because it's making it so I have to have these customer conversations where people are like, I use K8s at home, so I'm using Flux. And so I thought I was listening to all of this, and I listened to all the comparisons, and we thought about it. And I think the only way that I'm going to prevent that from happening in the future is if I go open up some pull requests to say, and here's a Argo version so that you can do all the same Kubernetes at home stuff just using Argo, so you can flip it as a switch and now it can be a flavor. I think that's the only way I'm going to head this off in the future, because it's just people get used to it.
We might see a repo in the future with someone trying to do what I did here with Flux with Argo, but it's not, I don't know, it's probably not going to be me. I think there's someone in the community who might be interested in doing it, but for me to do it, it'd take me a lot of time to, deploy Argo maybe on top of my Kubernetes cluster that's already running Flux, and, to seriously take a look at it. And I just haven't had that nudge to do that yet. So.
Well, on a related topic, in your repo, you're using Terraform. And so I'm curious, have you used the Terraform controller for Flux? So for those that aren't aware, Flux has a controller for Terraform where you can feed it Terraform resources and it will run those and try to keep them in sync.
Yeah. That's a really neat tool, and I'm using it in conjunction with OCI, as we talked about. So I build in my home repo, I build OCI images with just the Terraform code, and then Flux sees that, and then the TF controller, the Terraform controller in Flux, will then run a plan, apply, and print out any outputs to a config mapper to a secret. So I have Kubernetes cluster on my 6 nodes, and then I have a single K3s little tiny thing running on my NAS just for like node exporter, for shipping logs with vector. I think I run Nexus there as a pull through cache. So that cluster right there is not technically GitOps. That's deployed with Terraform with my other cluster. But yeah, you can do cool things like that, and that's a really cool benefit. I think I looked up in Argo and I didn't see if there was a way to do to deploy Terraform.
So there's not a Terraform controller available for Argo right now, and we did a little spike on it, and our conclusion was that Terraform state gets corrupted far too often and too easily for it to really be viable, and that we would rather push people to use something like Crossplane.
Yeah, some KRM solution. Yeah, it makes sense.
That works more natively and doesn't have those issues. And Crossplane has its own issues, in terms of resource usage and scaling it up. That's going to be a topic for a future episode. We're going to have some Crossplane folks on to talk about what they're doing to scale up their solution. So come back for that one, folks. But as far as the reliability, if you've been hands-on with it, do you feel like our concerns are founded, or do you feel like maybe it's not that big of a deal?
State corruption can be a huge problem in Terraform. I mean, some days I'm like, why does Terraform even do state? Like, why can't it just work like Ansible, and just apply these things, overwrite them if they exist? But that's Terraform's philosophy. So I can't really argue with it too much. If I want to use something that's not like that, I'll just use another tool. It's fine. Yeah.
It seems like the things that cause state corruption are drift. So like someone updates it and then that corrupts the state. That's a whole half of GitOps. Whole half of GitOps is detecting those kinds of things. So it's felt to me like Terraform is that it's not a change that we can make external in the community. It has to be Terraform that makes some kind of change to better account for operations that are happening against actual services and detecting those things.
Yep. And there's Pulumi as well. There's other, infrastructure as code projects out there.
So maybe this isn't a question for any of us, because somebody in the chat is asking, has anybody done Flux to Argo migration and what's the experience like? I would expect it would be pretty easy because ultimately I'm just going to be pointing at Helm charts and manifests. But you mentioned that there was maybe some CRD concerns that are specific to Flux, and I'm not sure if those would translate back if you just dropped them into Argo.
So
Was
the
that,
biggest,
wait, was that Flux to Argo or Argo to Flux?
It was Flux to Argo.
Okay. Yeah, go for it, Ryan. You're
I don't
probably-
help people with
So-
Argo to Flux. Well,
yeah, so if I was
I'm
going to
building on
do
one
what
of
I did backwards and I was going to switch from Flux to Argo, the things that I would have to consider is in Flux, you have the Git repository CRDs. You need to translate those into Argo's CRDs for Git repositories. You need to add in your concept of your project because that doesn't exist in Flux. So you're going to have to add in your project to ingest. It could be any Git repository to any cluster.
And a
That's up to
project
you.
could literally just be default project. I mean, you wouldn't necessarily have to put in things into separate projects, but yeah.
Right. You definitely could use default. I forgot about that. And then your next and your biggest change is going to be taking your Helm release CRD and Flux and changing that to either an application from a Helm generator, or you do your chart of chart method, which is you make a chart that references the chart, and then you application set across that directory of charts. And that's how I would do it in the other direction. The problems you'll start facing right then is if you're doing SOPs, that doesn't exist in Argo unless you add SOPs on top of Argo. And I don't know too much
It's not
about
built
that.
in. Yeah. It's
Yeah,
supported.
Yeah, it's not
but
built in. You have to slap it on top. So you have that to consider. And then another thing that you're also kind of missing in Argo that is really nice in Flux is, the substitutions. Not all of our substitutions are SOPs. Some of them are just things like the name of our cluster or maybe
Yeah,
an
Helm
IP
lookups.
subnet. Right. So those would be the biggest translations I would have to do if I was going to go from Flux back to Argo.
Yeah, it's interesting. I've seen that. I've noticed that actually Helm charts are started. I've seen a lot in the community that have shied away from using lookups in their charts because it's not supported in Argo. So depending on which charts you're using, may or may not be easy. But that's it's an interesting problem, and I would like us to get that Helm support there because I think that would actually be 90% of it. The secrets lookup is, as you kind of mentioned, it's a little bit of an anti-pattern because it would be better to use your secrets natively with your manifests and not try to inject them into your manifests, because then it's kind of, well, now you have to protect read access to those manifests, for example, if those things are supposed to be secret. So yeah.
But for normal, like just like Ryan was mentioning, like cluster name,
yeah,
like normal things, that would be kind of neat to have that substitution over top.
yeah, totally. Yeah, good call. Very interesting. Well, I'm pretty excited. I think this is it's a really cool community, and I'm really grateful to be a part of it. I'm really glad that somebody came running up to me a few years ago and said, like, you got to join this. And as soon as I came in the Slack channel, everybody was so welcome. The Discord, sorry, everybody was like so welcoming. They were just like, one of us, Kubernetes at home, let's go. And it was amazing, and the response has been amazing. And it's a very active Discord. So if you're not part of this Discord, you should check it out. It's K8s at home. You can just Google it and you're going to find it. The community there is incredibly positive. My only reservation is that we need a little bit more Argo representation in it. And so maybe we can work on that and round you guys out.
Yeah.
Yeah.
A little more Argo would be nice. We only have I think 20% of us using Argo still, and that would be great to have more Argo resources because Argo is a very powerful tool. It does some things that Flux doesn't do very well easier, like multi-cluster management, for example. So having those beginner resources that maybe are a little more home lab focused would be a really great thing to have in the Argo world too.
Yeah. As we come to a close here, I'll plug learning.codefresh.io, where we do have a GitOps certification for Argo, and it will train you how to do GitOps with Argo. And there's a GitOps fundamentals, and then there's also a GitOps at scale that focuses on doing things like application sets. We also show you how to do progressive delivery in there. We didn't talk about that at all today, but canary, blue-green deployments, that's actually in the fundamentals course. So if you haven't done that yet, I strongly encourage everybody do that, learning.codefresh.io. And then Davin and Ryan, anything that you guys want to plug as we come to the end of the show? We've plugged quite a bit, but maybe a book.
Yeah, just the Discord, come hang out, the Kubernetes at home search, which is awesome for looking up other people's configuration, getting ideas of how to deploy applications, and then the app template, which is just Helm for any application. And then, yeah, go ahead, Ryan.
I mean, yeah, I was about to say the same thing. Discord's great. I'm reachable over Discord mostly at the time. And yeah, just there's so many intelligent people, very smart guys over the K8s at home community where you can throw just about anything against the wall. And usually you'll get a response back that's somewhat reasonable, or maybe they'll say, oh, you shouldn't do this because XYZ, or yo, that's super cool, or things like that. It's super great community. I really enjoy it.
Yeah, it's definitely one of the best places to get a gut check. And if you say like, hey, has anybody tried X? There's probably 20 people that tried X and would be happy to chat about it. And I've been trying to be a little bit more active in the GitOps Discord. We have our own Discord that's called GitOps Champions. So if you're not part of the GitOps Champions Discord, that's a little bit different Discord because within GitOps Champions, it's really focused around the certification. And so there is, I suppose it's opinionated because we're going to tell you to use Argo. We're going to tell you to how you should set up your repositories. And we have, I suppose, a bit of a gospel about it that so there's an opinion to it. Whereas Kubernetes at home is a little bit more like, hey, man, everybody's just sharing their opinions and stuff. So if we get some cross-pollination into the GitOps Champions Discord, the way you join that is by joining the certification, learning.codefresh.io. So with that, thanks everybody. Companies hiring, you guys hiring? You looking for more Kubernetes folks, DevOps folks?
Usually every day. You can reach out to me on Discord if you're looking, or we have on our Discord, we have a job posting channel. So, if you want to sell yourself, go for it.
Yeah, perfect. Take advantage of that job posting channel. And same question, Ryan, any hiring or anything going on over there?
No, just keep an eye on that job posting. That's a really good place to look for people who are looking for very enthusiastic Kubernetes users. So if you're very well versed in Kubernetes or you want to grow in that path, definitely look at the very Kubernetes ecstatic people at the K8s at home Discord looking at the job post.
Yep.
Yeah, I mean, I feel like if you hire from the Kubernetes at home community, you're getting people that are clearly passionate about what they're going to be doing because they're doing it at home. That means just like Davin and Ryan have shown, they know a lot more about this ecosystem than they otherwise would. And so they can bring that into your company. So definitely do some recruiting in the Kubernetes at home community. Don't bug them though. No spamming. I'm like creating like problems for you. All right. Well, thanks everybody. That's going to close out for GitOps The Planet episode 5. I hope you all found it as fulfilling and exciting as I did. And I definitely have some homework assignments to go and upgrade my own cluster at home. So thanks again, Davin. Thanks, Ryan. We really appreciate you both.
Yep. Thanks, Dan. Thanks, Ryan.
Thanks for having us on.
Okay. Bye.
Bye.